Today in Algebra 1B, we're going to deal with our last section in Chapter 10 before the test. And today really has to do with being able to identify things as linear, quadratic, or exponential models. In other words, they want to know which one of these functions is going to fit the set of points that you're given the best. So let's take a look at some of these. First of all, an overall review over linear, quadratic, and exponential would probably be pretty helpful. So first of all, let's take a look. So on this, a linear one, remember a linear one is a line. And it has m, which is slope, and b, which is y-intercept. So that part's pretty common. Quadratic, this is what we spent our whole chapter doing. Remember, it can open up. That's when your a value is positive. It can also open down when your a value is negative. Exponentials are done in two ways, either growth, which is what this is, because this b value is going to be larger than 1, or they can be decay, which means it's going to decrease as it goes down, and that means your b value has to be between 0 and 1. So some kind of fraction or decimal or something like that. Now, if I look at this, so in most of these problems it's going to be enough to kind of see if they're straight or not, if they're curved. If they're curved, quadratic is the only one that can go through 0, 0. Exponential will never do that if it's curved. So kind of something to think about as we're going through this. Okay, let's look at our next one. Graph the set of points and tell the model. So really all we're doing in this is graphing our points. So negative 3, 6. Oops. 1, 2, 3, 4, 5, 6. Negative 2, 2. 0, negative 2. 3, 6. 1, negative 1, and 2, 2. So I can tell first of all by looking at this, it's curved and it's going up on both sides. So if I were going to draw something, hopefully this will show up. Yeah. Considering it's my pathetic drawing, but you get the idea. You could tell by looking at it that it is quadratic. So all you'd have to write on this one is, sorry about the writing, is that it's the quadratic model. Now, I want you to look at my graph, though, for just a second. See how it's kind of hard to see my points? I would encourage you, if you're going to make points, to exaggerate the size so it's easier to mark. Okay, let's try the next one. Same thing. We're going to go through and graph the points. So negative 2, 5. 0, 3. 1 and 2.5. And 2, 2. So first of all, if I want to draw a straight line, I'm going to tell you right now, I'm just going to use my line tool. I can see they're not going to fit on the line, which is my first clue that it's not linear. So if I were to look at that, let's see if I can draw with those dashed lines again. I can tell it's got a curve somehow for that to happen. So that means on this one I'm going to know that it's exponential. Sorry I did it again, but so it's an exponential model. Okay, let's look at the next one. Same thing, graph the points. So negative 2, 4, negative 1, 2, then 1, negative 2, and 2, negative 4. Now, I could already tell that if I were to do a line, they would all sit right on top of it. So I'm going to continue my line and then go in the other direction. So definitely tell it's a line so I know it's linear. And that's really all that the section is about, is to be able to choose the model that fits the best. Okay, let's try just a couple more examples. Okay, same thing. Tell which model is appropriate. So all we're doing is going through and actually graphing the points so that we know what model it fits. So let's take a look at the first one. So -2 and 1.45, which is like 1.5 almost. Then 0, 3, 1, 4, and 2, 6. So I could already tell, looking at something kind of curved, which means that on this one it would have to be exponential. Okay, next one. -2, -2, 0, 2, 1, 4, and 2, 6. I can tell because it lines up like that we're talking about something that's linear. So this one's going to be linear. Okay, now these have 11s in them, so I'm going to kind of just estimate a little bit off the graph. But -2, 11 would be like one past this. -1, 1, 2, 3, 4, 5. 0, 3. 1, 5. And 2, 11. Now I can also tell by the way this is set up, definitely talking about quadratic. So that's really the basis of this section.